And this one's take a look at solving a couple of quadratic equations. So the first one says x squared plus 18 here will be equal to 9x. So let's solve this. You want to make this look like this. Usually you want to have a 0 on the right side only. So for that reason, I'm going to do 9x minus on both sides like this. And then you arrange it so that the terms go like this. X squared minus 9x and then plus 18 is equal to 0. That's how you arrange the terms. Then from here you need to factor, so that means you need to multiply two numbers together to get 18, which is that. And the same two numbers added together have to give you -9, so that's -9. And then here, when I do that, think about this for a second. So if I try 6 and 3, 6 and 3 here will multiply to 18, but they don't add up to -9. So for that reason, you got to put negatives on these like that. So now -6 and -3 multiplied equal +18. That checks. -6 plus -3 gives -9. That checks. So use these to factor the expression there on the left side. So it looks like this now. Make sure you copy 0 always. And I'm going to put here x minus 6 and then x minus 3. Now I apply the principle of zero products. That means either x minus 6 is 0, or the other possibility is that basically x minus 3 is equal to 0, just the way you see it. So when I solve this here, I add 6 to both sides naturally enough, so that gives me x is 6. The other possibility is that x has the value 3. You just add 3 to both sides like that. So x equals 3. And then these are the values that are the right ones. So that's one answer, that's the other answer. If you wanted to, you could plug these back into the original and check. Remember, that means specifically when you check, use this one. Always check in the original. That means in our case, you would take 6 and you would plug that back into the first equation and show that the left and right sides are equal before you do any steps. You would take x equals 3, plug it back into the original equation and confirm that the left and right sides are equal. Either they are equal or they aren't. If they are equal, then the value of x you're checking is good. If the left and right sides are not equal, the value of x you're checking is not good. So this is one example. Let's do another one here. So this one looks like this. X squared minus 10x. And then here it's plus 25 is equal to 0. So when I work that one out, let's see. So I need two numbers that multiply together to 25 positive. The same two numbers added together have to give me -10. So I can experiment here a little bit, but you very likely will see pretty quickly that the numbers are 5 and 5, 5 and 5. And the only problem is these are not the right signs because 5 plus 5 is not -10. So adjust the signs also like that. And then I can factor this, so it becomes x minus 5 times x minus 5 is equal to 0. And then you can solve this. So here I'm going to take x minus 5 set equal to 0. I'm using the principle of zero products. So now either x is 5. If you solve the other one, it's also the same thing, right? Because like this is this one, and now that there represents solving x minus 5, the second factor. But that's the same thing in this case. You see x minus 5 is 0. So when you solve it, you get x equals 5 also. And then here, if you wanted to, you could check. So the check step basically means you would take x squared minus 10x plus 25, and everywhere you see x, you replace it with that 5. So I'll do something like this, 5, and then I'll put a 5 here, and let's be clear on what I'm doing. So I'm going to square this 5, so I'm plugging in the 5, minus 10 times the 5 from the solution, plus 25, and all of this supposedly equals 0. So now if you work this out using PEMDAS on the left side of the expression, you're going to have 5 squared, which is 25. 25 minus 10 times 5, that's like this, is 25 minus 50 plus 25 is equal to 0, and that does check. I'm going to put that as a very small side step up here, 9, okay? So back at step 8, 25 minus 50 is -25. Plus 25, does that equal to 0? I'm putting question marks because I'm checking, and the answer to that, of course, is yes. Because in the end, you end up at 0 equals 0. It checks. So this value right here, say for example, x equals 5, that is what we were looking for. Just like back here, x equals 6 was what we were looking for, and x equals 3 was what we were looking for. And that's it for this one. Thanks. I hope it's been helpful.